In this video, we're finally going to do a confidence interval and interpretation from start to finish. And we're going to look at an example in the context of the 2020 Senate race between Jon Ossoff and David Perdue. Before the 2020 election, UGA School of Public and International Affairs conducted a survey of randomly selected likely voters across Georgia. Respondents were asked about multiple topics, including their voting plans in the Senate race. Of the 1,053 who chose one of the two leading candidates, 540 said they would vote for Perdue and 513 said they would vote for Ossoff. So this is a little bit of a simplification to turn this into a binary variable. In the actual survey, there were some people who were undecided and also some people who planned to vote for a third party. But we're just going to consider the two main parties for now and construct a 95% confidence interval for the population proportion who support Perdue. So the goal of a confidence interval is always to estimate a parameter, and often the parameter is stated in the question. So a 95% confidence interval for the population proportion who support Perdue. So this population proportion, that's the parameter that we want to estimate. So that estimate is going to be based on our sample statistic. We'll use p hat to represent our sample proportion. And the sample proportion who support Perdue is 540 out of 1,053, which is 0.5128. And since this is a population proportion, it's good to stop and think for a second, what is the population here? So notice these are randomly selected likely voters. So that's our population, likely voters in Georgia. So this is different than a regular opinion poll where you're just trying to estimate the opinions of everybody in Georgia. And it's also more difficult than that because in addition to having to figure out what people's opinions are, we also are trying to predict who's going to vote. So that's another question entirely. So let's check our conditions. So the first condition is that we need to have a random sample. So we can see here that these likely voters were randomly selected. Remember that the margin of error is not going to correct any sampling or survey issues. So we just kind of have to assume here that the random sample was carried out appropriately and also that they did a good job of figuring out who the likely voters were. But we're going to assume that UGA did a good job with that and that our random sample condition is met. Next, we need to see if the sample size is large enough. So we're going to look at n times p hat. So that would be the sample size, which is 1,053, times the sample proportion, which is 0.5128. And that's actually just going to bring us back to the number of successes. So in this case, the number of people who plan to vote for Perdue. And this just needs to be bigger than 10. So we're good. And then we also need to check failures, so we're going to do n times 1 minus p hat. So that's 1,053 times 1 minus 0.5128. And this is just going to bring us back to the counts on the other side. So successes and failures in this case doesn't actually mean that like one is good and one is bad. That's just the labels that we use. So we have 513 here who said that they were going to vote for Ossoff, and that is bigger than 10. And so our sample size condition is met. That means it's okay to go ahead and use the formula that we've learned for confidence intervals. So the general formula here is the statistic plus or minus a critical value times the standard error. So we already have the statistic. We know that our sample proportion is 0.5128. To get our critical value, we would need to use the jump distribution calculator. So we're going to go to Add-ins, Teaching Modules, Distribution Calculator. Change the type of calculation to Input Probability. Change the percentile options to Central Probability. And then since this is a 95% confidence interval, we're going to put in 0.95 here. And this number is the critical value, 1.9600. So that's our critical value here. And then for the standard error, we're going to need to use this formula. So in the previous unit, we did p times 1 minus p over n, all under the square root. But here we don't know what p is, right? That's the purpose of this whole confidence interval. So instead, we're going to plug in p hat. That's our best estimate for p right now. Okay, so I'm going to do the square root I'm going to do 0.5128 times 1 minus 0.5128 all over the sample size, which is 1053. And I think I'm going to calculate this in pieces just so we can see what the margin of error is. So I'm going to do 0.5128, and then I'm going to calculate this part. And I don't usually show the calculations where I plug things in, but maybe that would be helpful at least just once. So I use the Desmos Scientific Calculator. And the reason that I like this calculator is that it doesn't show everything with just like parentheses and basic symbols. It actually shows it written out like an equation. I'm going to do 1.9600 times the square root, and then under the square root I want a fraction. So on the top of the fraction I'll do 0.5128 and then times 1 minus 0.5128, and then in the denominator I'm going to put the sample size 1053. So it's pretty easy to see here that this matches up with the equation that we wrote out earlier. And this gives us our margin of error, 0.0302. So plus or minus 0.0302. And this number that we're adding and subtracting on each side, this is the margin of error. So we've got our statistic plus or minus the margin of error, and that comes from multiplying the critical value and the standard error together. So when we put it together, our interval goes from 0.4826 up to 0.5430. So that's our 95% confidence interval. So in the next activity, you're going to interpret this interval and then also think about whether it's reasonable to think of the election as tied, and make sure that you come back here and write down your answers in your notes once you're finished.